All right, this is Mr. Wyrick, and I'm here today to go over the information that you'll need for our quiz today, which is the applications of the slope and distance formula. So you're going to be looking at some different stuff to see how far apart it is, and you're going to be working pretty close with some slope things as well, so I wanted to make sure I reminded us of that. So first off, there's the distance formula. If you look in the notes that I gave you a copy of, I put them in the assignment for today. The distance formula is in there, and it's the square root of x2 minus x1 squared plus y2 minus y1 squared. I don't like using the distance formula. I feel like the distance formula is kind of confusing. It's kind of like the slope thing for me. I just use something else instead, and what I use is the Pythagorean theorem. I'm very used to triangles and working with triangles, and if you need distance, it's always this x2 minus x1 actually relates to our change in x. So if we're looking at this triangle down here, this A here would also be our change in x. The y2 minus y1 is the change in y. So this distance right here, so we take that, we square both of those just like we would here, and then down here on the Pythagorean theorem, that's equal to c squared. So in order to get c, this distance, we would have to take the square root. The distance formula just takes the square root and makes that part of it. So they're not just closely related, they are exactly the same thing. It's just a matter of preference really, and again, like I don't like the x2 minus x1, the y2 minus y1. I like to just find that distance because with the triangle, if I were to flip this triangle upside down, that c would be the exact same distance. So I don't need the rest of that information. I need my change in y, my change in x, and I can call that good. The equation of a circle, they do throw a couple of questions on there today where you'll have to find distance, and they're talking about the equation of a circle all of a sudden out of nowhere. We haven't really talked about circles. For a center point of HK, right here in the middle of the circle, it's x minus h squared plus y minus k squared is equal to r squared. Wouldn't you know it, that is also based off the Pythagorean theorem. If we were to draw a nice little right triangle right here, this radius would be my hypotenuse, the distance that we're trying to find. And no matter where we move that right triangle, it's the exact same distance from the center of the triangle out, or from the center of the circle out, because it's always the same hypotenuse of that right triangle, okay? It seems a little confusing, but that circle equation is the Pythagorean theorem, and the Pythagorean theorem is what they use to make the distance formula. So it's all very, very closely related. So, finding the distance from 0, 0 to 4, 3, we're going to find our change in x. That's going to be our a value. So that's 0 to 4, that's 4. From 0 to 3 is a distance of 3. So we have 4 and 3. We're going to do 4 squared plus 3 squared. We square those. Okay, 4 squared is 16. 3 squared is 9. We add them together. 16 plus 9 is going to give me 25. And then I would take the square root of that, and that's going to give me 5. So the distance, as direct as you can go from 0, 0 to 4, 3, is going to be 5 units. Okay? On the next one, we have -3, 5 to 5, -8. Again, I just like to find the distance. From -3 up to 5 is a change of 8. From 5 to -8 is a change of 13. So 8 squared is going to give us 64. 13 squared is going to give us 169. So 169 plus another 64 is going to give us 230 something. The basic gist of this one is 16 squared would be 256, and 15 squared is 225. So it's going to be between 15 and 16. For the purposes of what we're doing, you can just use your Desmos calculator. You can use the calculator that's available to you, the TI one that's on your Chromebook, and you can calculate that distance to a couple of decimal places, but you may see the exact answer. And if the exact answer is put on your paper or on your quiz that you'll see today, that's going to be the square root of whatever we can reduce that, okay? And we'll talk more about reducing the square root later, but basically if the answer has a radical, find the decimal equivalent, okay? If they have 5 square root of 6 or something like that, then find that 5 square root of 6 and see if that matches up to the answer, the decimal answer that you got, okay? Extra information for the quiz, you may need to identify quadrilaterals. They did put some information about, you know, by determining the distance and the slope here, what's going on. For the parallelograms, the opposite sides are parallel. You usually see these as tilted, and the opposite sides are congruent, but just the opposite sides. So these two sides would be congruent, and the top and bottom would be congruent. For the rhombus, all the sides are the same. All 4 sides are congruent, and the opposite sides are parallel, but we don't have that 90-degree angle like we would in a square. On the rectangle, the opposite sides are congruent, the opposite sides are parallel, and all of the angles are 90, but not all 4 sides are the same. And then the square, of course, is the most restrictive you can get. All 4 of the sides are the same. All angles are 90 degrees, so you need that perpendicular slope of those lines going through there, which means you need to put your slope down, flip it, and reverse it. Always make sure that you are going through that stuff there, okay? So, distance formula, it's the same as just working the Pythagorean theorem, so make sure you understand how to do that. You can type this stuff in on the calculator pretty easily, and you do have a calculator available to you if you want to try to do that. If you have any other questions, I will be back here on Wednesday, and we will have a makeup day on Wednesday, so that will help. Thanks.